Hello, welcome. Today we're going to be looking at using Gauss Siedel's method to solve simultaneous linear equation or linear simultaneous equation using Gauss Siedel. In the previous class, we looked at using Jacobi method. We're going to find out that Jacobi method and Gauss Siedel method are almost the same, except for a few things. So first of all, these are the three simultaneous equations. Using the first one, make x1 the subject. So when you write x1, you're going to have all this going over here. You're going to have 9 minus x2 minus x3 all over 4, which is the coefficient of the x1. So that makes x1 the subject. You do the same for x2, but this time around using the second equation. So it's going to be minus 11. You take this one over, minus 11, you take this one over, minus 2x1, then this is supposed to be x2, sorry. So we have x2 equal to minus 11, this one going over minus 2x1, this one going over minus 3, all over the coefficient of x2, which is 5, this time around minus 5. Remember in the last one I solved for Jacobi method, I didn't put minus 5 here, so it's actually there should be minus 5 since there is minus 5 here, so that you can actually cancel out to have everything to be plus. Now you make S3 the subject from here, so that you're going to have this is 0, so you're going to be having this over here x1, having this over here 3x2, all over the coefficient of x3, which is 5. So you are now having these three equations. And that is what you're going to use for your iteration. So to do the iteration, prepare a table, put the variables here, x1, x2, x3, then number of iterations. Now use initial value assumption of 0, 0, 0. The only difference between this and the Jacobi method is that now to solve for this, you bring this down, so you're going to have 9 minus x2, so value of x2 here, you're going to use x2 as 0, minus x3, value of s3, also use x3 as 0, all over 4. So this is going to give you 9 over 4, which is around 2.5 or 2 points, around 2 point something. So now, to solve for x2, when you put this same formula, 11 plus 2x1, instead of using 0 now, you're going to use what you have here. So let's assume, since we are going to be assuming for the rest, let's assume we have m. After solving this out, 9 over 4, you know what it is already. So you're not going to have 2m plus x3, you've not solved any s3 before, so you're going to have 0 equal to all over 5. So let's say you got n after solving this. Now to find x3, you're going to have x1, you already found x1 as m, plus 3x2, 3 brackets, x2 you already found as n, no longer 0, all over 5. So the values you are using is the value that you already found previously, instead of continuing to use, instead of using the whole of this and now using the whole of this. So let's say you solve this out, you have L. Now to solve this one, you're still going to use this again, 9 minus x2. The latest value of x2 is what? N. Minus the latest value of x3 is what? L, all over 4. To find your Q, that's the latest value of x1 now. So to find x2, you're going to have what? 11 plus 2x1. The latest value of x1 is now what? Q, minus the latest value of x3, which is L, all over 5. Now to find x3, you still use this equation. x1, what is the latest value of x1? Q now. Plus 3, what is the latest value of x2? P, all over 5. To give us, say, R. You understand? So you do the same thing here. x1 1 will still be, you use the first equation, 9 minus, what is the latest value of x2? S2 latest value is p, minus, what is the latest value of s3? R, all over 4. Now x2, what is the you have 11 plus 2. What is the latest value of x1? You already have here. Let's say g, it's going to be g here. Plus, what is the latest value of x3? R, all over 5 equal to h. Now to find x3, you go x1. What is the latest value of x1? G, plus 3. What is the latest value of x2? H, all over 5. To find k. So that's how you keep finding. You use the latest values. Once everything here is similar to what is here, once what is here is the same as what is here, you know that you now have what? Convergence. And once you have convergence, you stop. So that the latest value of x1 will now be g, that of x2 will now be h, and that of x3 will now be k. So very, very importantly, the same method for Gauss Siedel and Jacobi, only that in the iteration, you use the most recent value of everything. Unlike having to do this, using this for this one, and using everything here for this one. As you're doing this one, the immediate value of x1 that you have, that's what you substitute immediately. The ones you've not done, you can use 0 for them. But anyone that you've done, just use the value immediately to find new values. Then when you're here, you use the most recent. You want to put x, once x1 is in this one, know that you're going to use the most recent x1. So like that, you solve that. Whenever you're having similar values here, you know you have convergence. That's where you stop the iteration. If not, this fourth one, you can get to fifth, and so on and so forth. So that is Gauss Siedel. Please take note, in the last class, we didn't put -5 here. But because I put it now, that's why I'm able to get all this to be plus. So you check the solution, the procedure for that of Jacobi method. Make sure you make this correction. Thank you. I think we've done well for this. Thank you very much. Please hit the subscribe button if you like this, share this, support us in any way you can. Thank you. God bless you.